Welcome to the physics of pole vault. Pole vaulting is a pretty wild and wacky sport, just filled with physics. Just in case you don't know what pole vaulting is, which would be silly of you, it's when someone runs as fast as they can holding a pole in their hands. They proceed to stick their pole into the ground, and while still holding on, jump as high as they can over a bar and onto a super comfortable mat. Some people are really good at this. Some people aren't. Vaulting is just a bunch of energy being converted from kinetic to potential back to kinetic again. In the words of the world's greatest ex-coach, Jason Cleese, maintain your speed. In the words of the rookie coach, Line, speed is key. Now it sounds like these guys don't know what they're talking about, but they're right. Speed is everything. Without speed, you don't have a vault. The funky thing is that we can actually use equations to figure out how high someone could ideally jump. These equations don't take the bend of the pole, the power of the jump taking off, or the swing in midair into account though. To use this equation, we have to put kinetic energy and potential energy equal to each other. This ends up looking like 1/2 times mass times velocity squared is equal to mass times gravity times height. Since the vaulter's mass will be the same, we can take that out of the equation. After that, we can divide both sides of gravity, so we're ready to solve for height. I decided to put myself into this equation and see how high I could jump. I figured out that I can run about 5.92 meters per second when I'm sprinting. This ends up being about 2.79 meters, or just over 5 feet tall. In reality, I'm jumping about 8 feet 3 inches. Because I'm not an ideal person, I lose some momentum in my poor form. I don't keep my body rigid enough, so I absorb some of the energy with my body when I plant the pole. Some scientists wanted to see how high the fastest man could jump, so they applied this equation to a world-class running speed, about 10 meters per second. After plugging the numbers in, scientists figured out that the highest ideal height would be 6.1 meters, or 20 feet. This is pretty accurate because the world record holder, Sergei Bubka, jumped 6.14 meters. Bubka probably didn't run 10 meters per second though. Other factors played into his staggering height, like the bend of the pole, the jump, and the invert. Bubka even used his arms to push himself off the pole into the handstand position to gain a little extra height. But the calculations were still pretty spot on, which is impressive. Most scientists believe that the world record will level off soon, if it already hasn't, because physically, humans shouldn't be able to jump much higher. Bubka has held the record for almost 20 years now, so scientists are probably right, but when aren't they? You're probably wondering why pole vaulters get that wacky bend in the pole when they vault. The bend in the pole is all of the potential energy that was just you running, called gravitational potential energy. Once it slows down laterally, it releases that energy as kinetic energy in a nice spring that pops you up in the air even higher. Then you fall down with all your kinetic energy with the help of gravity until you hit the good old mat, which absorbs all of it. So next time you're pole vaulting, just think about how great the transfer of kinetic to potential energy is. And don't forget to thank physics for all the fun you're having. And that was pole vaulting and physics.